All right, so this is just kind of an intro day on chapter 2. We're going to talk about rational exponents again, which is a fraction. So if you had b to the 1 over n, like 1/2, it would really mean square roots. If you had b to the 1/3, it would be cubed root. You remember this? Okay. They get a little more complicated when the denominator or the numerator is something other than 1. If you have something like, see if I can get my cursor working here. So if you have something like b to the 4/3, what does that mean? Okay, cube root of b to the 4th. It can also be written the cube root of b with the 4th on the outside. Okay, means the same thing. All right, and then we're going to talk about reducing those today. Before we do that, I hope these look familiar. If you have x to the 3rd times x to the 7th, you get x to the 10th. If you have x to the 7th over x squared, it simplifies to x to the 5th. Are we good? If you have x cubed to the 4th, what do you do with those? Multiply. Okay. Anytime you have a negative exponent, there's lots of possibilities, but if we had 4m to the negative 3rd, what does that mean, guys? That's when everybody gets wrong. It's 4 over m to the 3rd, or 4 times 1 over m to the 3rd, which is the same thing. Are we good? The 4 does not have, I didn't write it very well, but the 4 does not have an exponent other than 1. What about when it looks like this? That's the 6. Yeah, these two belong where? Yes, so then you end up with an x to the 8th. And what if it's 2/3 to the negative 2? What does that do? Means both the 2 and the 3 are on the wrong side of the fraction bar, right? And it has to be squared, so you'd end up with 9 over 4. Everybody okay? Okay. Anything to the 0 power? 2x cubed all to the 0 is just 1. Okay, I think we covered all those ideas. This is just another slide with the same crazy ideas. This is true, guys. If we have 2x cubed y to the 3rd, and we're supposed to do it all to the 4th, it means 2 to the 4th and x to the 12th, y to the 12th, because you're multiplying exponents there. Are we good? It applies to all of those things. We should not use the word distribute there. Distribute is across addition and subtraction, and you don't distribute exponents. Use it, whether we really mean to or not. All right, yes. Do I have enough graphics for you? All right, this is the one for today. Rational exponents, a over b, you can put the a inside or outside, and the b is the power of the radical here. Okay, so 4 to the 1/2 can be written the square root of 4 to the 1st, or the square root of 4 all to the 1st. Do we ever write that 2 out there? No. Okay. Let's look at the worksheet. We're supposed to rewrite this with a radical. What would this look like if we rewrote it with a radical? 6th root of x to the 7th. Everybody okay? Guess what? It's pre-calc. We don't get to stop there. What else is there to do? Any ideas? Sixth root of x to the sixth would be what? So then what's left over? 1x left in there, right? This is 1 and 1/6. 7/6 is 1 and 1/6. So 1x can get out of the little jail, and there's a sixth root left over. It says when you have an even root of an even power, and the result is an odd power, you must use the absolute value. Okay, let's go back to this question. If I put a positive number in here and do it to the 7th power and then take the 6th root, I can only take the 6th root of a positive, right? But if I put a negative in, I can raise it to the 7th power, but can I, when I 6th root it, it can only take the 6th root if it's positive. This is my concern. When we do this right here, if I simplify that down to this, you with me? I can put a positive or negative in here and do it to the 6th, yes, and then root it. But the answer is going to be only what kind of number? Positive. Can't be negative because we did it to the 6th power and then we 6th rooted it. So we're supposed to have absolute values here. I'm not going to make a big deal about this, but can you write this rule at the top of your paper? When you find an even root of an even power and the result is an odd power, you need absolute value. Even root of even power if your answer is an odd power, then you need absolute value. The square root of x to the 6th is x cubed. Because this really means x to the 6th to the 1/2 power. Everybody okay? But the problem is here, I can put in either a positive or negative number. But here, because it started out like this, I have to have what kind of an answer? Positive. Okay? I do hereby solemnly swear I'm not going to put this on a test or quiz. Probably. I don't think this is that big a deal. When you look in the back, it's going to have these absolute values. All right, let's go back to this one. Is this an even root of an even power? This is an odd root, right? The root is a cubed root of a 4x to the 4th. Anybody know what that's going to simplify to look like? This is what you did in Algebra 2, yes. You left it that. What can we take out, Sam? Yes. But we're recording right now, so could we do this question, guys? Yes, you can take out 1, because the cubed root means for every 3, 1 gets out of jail, right? So there's 4 of these. So the cubed root of 3 of them, in other words, if I rewrote it like this, okay, This guy becomes just a 4x, but this plain old 4x is still in here. Why didn't I need absolute values? It's all a cube root, so it can be positive or negative the whole time, right? It's not a fourth root or a square root. Are we good? All right. How about this one? What does this mean? Does that simplify? What's the square root of 64? Not plus or minus, but just 8, right? It's called the principal root. Yes? Because there isn't a cube root of 4 that comes out nice. Because this whole quantity was there 4 times. This means 4x times 4x times 4x times 4x, and then the cube root. Okay? So because 3 of those are cubed, so then I have 4x quantity cubed, the cubed root of that, which would just be 4x. Yes? But there's one guy left over, and he's the cubed root of that one that stayed in there. If the 4 had not been in the parentheses, we'd have a whole different ballgame. Is that what's confusing you, maybe? If it just said this, you would have had a 4 already on the outside, separate from the whole problem. Then because there's 4 x's in there, one of would have got out, and there still would have been 1 in here. Is that the difference between those help to see that? Okay. All right, guys, can we finish this one? 64 n to the 6th, the 1/2 power, is the square root of all that. What happens? Sorry. Okay, 8 is correct, and n to the 3rd is correct. Now, what's the rule? An even power, or even root of an even power that turns out odd. Is that what happened? It was a 1/2 or square root, which is a 2, of an n to the 6th, which is an even, and it turned out n cubed, which is odd. It's supposed to have those. Because if I put a guys, let me explain one more time. If I put a -2 in here and type this in my calculator, what's the answer going to come out? Yeah, it wouldn't matter. Yep, absolutely. If I put in 64 times, whoops, let me get some parentheses going here. 64 times parenthesis -2, close parenthesis to the 6th, close that parenthesis, and then all to the 1/2, and mine is not doing the font the way yours is probably. We get out 64. I think I had all my parentheses in there. Okay. Now, if I put it in down here, if I just do 8 times -2 to the 3rd, I'm going to get -64, which is not the same, right? If I put the absolute value there, then does it make it positive 64 so it's the same? Does that help you see a little bit what we're talking about, why the absolute value is needed? Okay. All right. What's the good news? We're doing a cube root over here, so it doesn't matter about the absolute values, right? Okay. What do you want to do? Ideas? Cube root of 8m to the 9th and then square it? This is Blurta's idea. Is that okay? Yes. Okay. So what is the cubed root of 8? 2. What is the cubed root of m to the 9th? Cube root means 1/3 power. So a third of 9 would be 3. Are we done? We still got to square it out there. So we get what? Okay. Do we need absolute values? All right. We wouldn't anyway because it's an even power. But let's go back up here. Let's talk about the other order we could have done this in. What is the other order? Anybody know? Um, 8m to the 9th. We still got to square the whole thing in there though, right? Yeah. So what's 8m to the 9th squared? 8 squared is 64. M9 would be M18. Okay, we do know the cubed root of 64. We're learning our cubes pretty good, right? And this takes a third of that, so we'd get same thing. Yay! I'm kind of with Flirta. I would have made it smaller before I made it bigger, just because sometimes when you square it first, it gets so big you don't know what's the cube root is, but that one was pretty easy. Okay, now we're just going to use exponent powers. And it says you've only positive exponents in our answer with no fractional exponents in the denominator. We're going to have to do a little rationalizing when we're done. Okay, what happens first? What do you want to do first? Because I want to do the order you guys want, because you could do this problem a lot of different ways. What do you want to do? The 2 and the 3, okay? We're going to have a 6. What else? An x squared times an x is an x to the 3rd, Madison said. We good? Okay, now what do you want to do? No crying. We can leave y to the 4/3, yes? And where does this guy go? He goes down here. Now we can have fractional exponents, but we can't have him in the denominator. What's the rule when you have one here and one here? You subtract. Could we have done that back here? Could we have just added the exponents? Okay. Because they have, so we did on this 2 right here and this one, right? We added the exponent and got 3. Okay, so at some point we have to deal with those exponents. I'm going to be the math teacher who says, let's think about this and do it the right way, but you can use your calculator. I don't care. What's the common denominator for 3 and 2? Okay, so this guy multiplies by 2 over 2, and this multiplies by 3 over 3. You know what? There's part of the SAT that's no calculator, right? And if you go to Rock Valley, the placement test is no calculator, and this is how it starts with fractions. Okay, so this is 8 over 6, and this is 3 over 6, and we're supposed to be subtracting. So we get what? So this simplifies to 6x cubed y to the 5/6. We could rewrite that as like the 6th root of y to the 5th, but it says we can have fractional exponents. We just can't have any in the denominator, and we got rid of the denominator. So, oh, happy day, we can be done, okay? All right, what do we do first, or what do you want to do first on this one? No crying. Okay, so what are we going to do with that 3/2? What's the rule say? If you have a to the n, b to the m to the x, I don't know, what would you do with those? You'd get a to the nx and b to the mx, right? This multiplies. Yes, distributed Precalc, exactly. Okay, so what's -2 times 3 divided by 2? -3. Are we okay? All right, and then when we multiply these two, we get a lovely 6/6, which is 1, or y to the first, or just y. So whoever said this was looking disgusting, I think it's not as bad as we thought, yes? Now what? What do you want to do next? You want to do that next? Okay. So we have this guy's going to go to the bottom and this guy's going to go to the bottom. So I guess I'll leave them in the order I have. You can do whatever order you want. Now what? Yes. If we wrote this out, we'd have an XX, and this was an XXX, so there'd be 1 left down there. This y will divide one of these y's out. So what's left? Okay. Anybody would have done that in different order? Reagan, where did you go different? Yeah, that's what I was thinking right here. I probably would have added those powers together and got a -1. And then I would have added these powers together and got a y to the -1 and then written it that way. Yep. Anybody do anything different? As long as you don't break the rules of exponents, you're all good. Okay. What do you want to try on 7? Multiply those together. What do we get? V to the 15/8. Is that the disgusting answer we get? And then we have a u that's just to the first and a v to the third. Okay. What do you do when you have v's to 2 different powers? Okay, yes, because we need to add them, yes? 15/8 plus 3. What's 3 as 8ths? 24/8. So 15/8 plus 24/8 would be 39/8. Okay. So if we want, we could just write 1u and b to the 39/8, right? And let's leave it at that, but does anybody know how that would look if we wrote it as a radical? How many times does it go into 39? 4 times. And how many are left over? That's what you'd get if we were writing it the way we did at the top. Because 4 goes in evenly, so 4 of them get out. And then there's 7/8 left over, so that could be written like this. All right, this is fine. Number 8. No crying. Where do you want to start? Do this thing first? Okay, so I'm going to leave the top by itself. What happens down here? 2 times 1/3 is 2/3. V to the -2 times 1/3 would be v to the -2/3. And there was already a 3/2 and a 4/3. Okay, then what? Move this one up top. Make you feel better? Cross the line, change the sign. That's the way I used to teach it, right? Change the sign on the exponent to positive when you move it up there. All right, now what do you want to do? add them together. Can we use our calculator yet? Up top we have a u. What's 3/2 plus a 2/3? This is going to be 9/6 plus 4/6, 13/6. Did someone use their calculator and get 13/6? Yes? I didn't make a mistake, did I? Okay. What's happening in the denominator down here? Well, don't we get to do the same thing again? This time there's u to the 2/3 and u to the 3/2, so it's going to be u to the 13/6, isn't it? And what do we got down there for v's? V to the 4/3. Now what? Okay, so one of those is going to cancel how many of those 6? 6, right? This is 6/6, not 16th. Okay, 6/6. So what's going to happen? Are there going to be u's left on the top or the bottom? Bottom. How many? 7/6. All right. What about v's? 13/6. This would be how many 6? If 8/6, right? So we have 5/6 left up top. I'm thinking a calculator would have been our friend. What do you think? What does it say in the directions? No fractional exponents in the denominator. Okay. We need to do something that will make this come out a whole number. Okay. If we raise the top and bottom to the 6th power, yes. But can you randomly do that to something? Can you randomly raise something to the 6th power? If it's an equation and you can do both sides to the 6th power, yes. But can you randomly just decide I'm going to take a number and raise it to the 6th power? What? No. What's the only thing we can do? Well, we can do something to the top and bottom, right? Are you totally lost? Okay. What are we going to do when we do this to the top and the bottom? What's going to happen to the exponents? They're going to get... When you're multiplying, what do you do with the exponents? Add them. So I need to add some more so that it comes out nice. 7/6. Patrick says 5/6. Does that work? You get 12/6. So now what do we have? Yeah, that was a great answer. Headache. U to the 5/6, V to the 5/6. I just wrote the U in front of the V. And in the denominator, we have U to the 12/6, which is U squared. We had to multiply by something so that when we added the exponents, it would come out nice. Like as in, it can't have a fraction anymore. So yes, okay. If we have this, if we could randomly do this, yes. No, because we've gotten rid of the, if we simplify it again, we're going to have a fraction in the denominator again. This is illegal, Ariana, because there's no equals anything, so we can't randomly decide to raise something to a power. We can, because what we did was we multiplied the top and bottom by the same thing. That's allowed. We were trying to get the denominator to not have a fraction in it, and the only thing in the denominator was the u. It's okay for the top to have fractions, just not the bottom. This is not looking like it's going to be on a quiz, okay? Let's keep going. Number 9. What do you want to do first? You want to clean it up inside and then flip it over, or you want to do this -2? You want to flip it over first? Okay. Now there's still what out there, though? A 2, because all I did was flip it over. Now what do you want to do? You want to clean it up inside, or you want to square it all? Okay, square it. So what will it become? All I did was, they told me they wanted to flip it, so I just flipped everything and took care of that negative. What will it become? X squared. Y to the -4. I'm multiplying all the exponents by 2, right? X to the, what's 5/4 times 2? 10/4, which reduces to 5/2. Everybody okay? And in the denominator? Okay. What do you want to do next? Adding, subtracting, add the top x's, okay? So what's 2 plus 5/2? Yes, this would be 4/2 is the same as 2, so we get 9/2 up there. Okay, can I move this y guy to the bottom at the same time? That won't hurt anybody's feelings. We have an x to the 4th and a y to the 4th. Are we done? Okay. We're never done, right? It's freaking. All right. What happens here? Subtract. 9/2 minus 8/2 would be 1/2. What's the good news? It's in the top, so we can leave it. Okay. How many of you would have done that in a totally different order? Okay, can you tell me what you did, Reagan? I probably would have done this, guys. I probably would have canceled that x with one of those right away. And then I might have moved this up here. This is going to flip the whole thing over, right? And square them all. So I'd have an x squared y to the 4th. And when I multiply square this, I get 5/2 negative, which moves it to the top. And then if I subtract right there, I get 1/2 and 4. So I did it a little bit different order, but we got the same answer. Reagan, did you figure out what you did? Did you? All right. Is this the last one? Last one on this side? Okay. What do you want to do first? Okay, what are we doing down there with those? Multiplying. Yes. So 4 times 3 divided by 2 is 6. Ooh, good news. No fraction down there. All right, now what? I think it's not as good news as you think because we could just call it multiply. Okay, what's happening? Who wants to go? What do you want to do with this mess? You want to add the top? Okay, what's 2 plus 3 halves? Can't I just do this? Make that a 4? Where does this go? Okay, I still have to deal with that up there. Okay, we now have fractions in the denominator. We actually still have to subtract these, right? What's 3 halves minus 4? It's in the denominator. Wait, guys, does it make sense that there was more of them on the bottom? Okay, so we end up with nothing in the numerator except a 1, and an x, whoops, to the 5 halves, and a y to the 1 half. Well, I moved it to the bottom, that's why it's negative. Okay, we don't get to multiply everything by something. Yes, we're going to do something. Okay. Have to add to it until it's a whole number. So how many x's do we need to add to it? 1 half. So that we'll have whatever we do to the bottom, we have to do to the top. That's just a form of 1. And what do we have to do with the y's? Same thing. Okay, so what do we get on the top? Let me get this out of here. Yes, x to the 1 half and y to the 1 half. What happens down here, though? This becomes x to the 6 halves, which is 3, and y to the 2 halves, which is why can't you leave a fraction in the denominator? Because what does a fraction exponent mean? Yes. You can't have a radical in the denominator, right? If I rewrite this as a radical, guys, it's the square root of xy over x cubed y. Does that seem kosher? No radicals in the denominator. That's why we can't have fractions down there. All right. I have a couple more slides for you because you have a few book pages you need to do. This is an example out of the book. I don't even know if I assigned this, but does anyone know what this means? What power of 2 is 32? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. To the 1/10, yes? And down here we have 2 to the... Now what do you want to do? What does the top become? What do you do with those? 5 times 1/10 is... Yeah, 5/10 or 1 half. Does that simplify? Can I subtract? What? This becomes 3/6. When we subtract, we get 2/6, which is 1/3, right? On a good day, so what's left? All right, I don't even know if I assigned any of those. This I did assign. Does anybody see what we're doing here? Honestly, what you can think of this two ways. I would do this, I think. One-fourth, yes? Okay, so 21/4 and 15/4. How many of those are nice? This is 5 and 1/4, yes? And this is 3 would be 12 and 3/4. I don't think this is going to be your favorite method. Hang on. So now we have an x to the 5th, a y to the 3rd. They're not under a 4th anymore. What can we do with those if we put them back under a 4th root? X, y cubed. Okay. You did these last year. You did these last. Oh, what did I just do? Just kidding. I don't know what I did. Okay. But we're just going to finish. This is how I think of it, guys. How many? 4 goes in here evenly how many times? 5 times. What's left over? 1. 4 goes in here how many times? So I got a y to the 3rd out here. How many leftovers? Okay, hang on. I didn't write this well. All right, last one, and then I'll do the one off the homework that she's asking about. What's going to happen here? Goes in there once with how many leftovers? Leftovers stay in here. Okay? 1x, 3 leftovers. Okay? Okay. That's a much better way of explaining it. Now, that is one of your homework questions, by the way. So this is the assignment, guys. Please listen. Guys, worksheet 1B, you only have to do the evens. And then there are 5 book questions. This is back on page P17 at the beginning of the book, okay? All right, now, Madison, what is my question that I'm trying to help you with? On the worksheet? It's this one, right? Okay. So it's 5x squared and then the cubed root. I don't think there's anything nice you could do with that. Yes, that would be fine. Either one of those would probably be okay. I like your answer better, but. All right. Everybody good?